What if I told you that beneath your feet right now lies evidence of a world so alien, so utterly different from anything you've ever imagined, that it would make the most exotic planet in science fiction seem mundane by comparison? A world where massive landmasses drifted across the globe like colossal ships, where entire mountain ranges were born and died, and where the very shape of our planet was constantly reshaping itself in ways that defy everything we think we know about solid ground. Today, we're going on a journey back in time, not just millions, but billions of years, to explore the forgotten labyrinths of Earth's ancient supercontinents. These weren't just bigger versions of the continents we know today. They were geological monsters that created landscapes and climates so bizarre that they've left scientists scratching their heads for decades. And here's the kicker. The mysteries we're about to uncover aren't just academic curiosities. They're actively shaping our understanding of how life evolved, how climate works, and what the future of our planet might look like. But before we dive into these geological time machines, let me blow your mind with something that happened just a few years ago. In 2019, researchers discovered evidence of a supercontinent so ancient that it existed when the Earth was practically a baby, geologically speaking. This discovery didn't just add another chapter to Earth's history books. It completely rewrote the prologue, revealing that our planet's continental dance has been going on far longer and in far stranger ways than we ever imagined. The story begins with a simple but profound realization that geologists made in the early 20th century. Have you ever looked at a world map and noticed how the continents seem to fit together like puzzle pieces? Well, turns out that innocent observation was the key to unlocking one of the most mind-bending secrets in Earth science. But what those early scientists didn't realize was that they had stumbled onto evidence of something far more spectacular than just continents that had drifted apart. They had discovered the remnants of geological superpowers that had dominated our planet for billions of years. Let's start our journey with Pangaea, the supercontinent that most people have heard of, but probably don't truly understand. Picture this. About 250 million years ago, there was essentially one massive landmass surrounded by a single enormous ocean. But Pangaea wasn't just big. It was a climate-creating, weather-controlling, evolution-shaping monster that made life on Earth incredibly different from anything we see today. Here's where it gets really wild. The interior of Pangaea was so far from any ocean that it created what scientists call mega-monsoons. We're talking about seasonal weather patterns so extreme that they would make today's most severe storms look like gentle spring showers. Imagine rain so intense that it could carve canyons in just a few thousand years, followed by droughts so severe that they turned vast regions into landscapes that would make Mars look hospitable. But the really mind-bending part about Pangaea isn't just its size or its extreme weather. It's what happened when it started to break apart. This wasn't like tearing a piece of paper. This was like watching a geological symphony in ultra-slow motion, where each movement of the Earth's crust created new oceans, new mountain ranges, and entirely new possibilities for life to evolve and spread. The breakup of Pangaea literally split families of species across newly formed oceans, creating isolated populations that would evolve in completely different directions. This continental divorce was so significant that we can still see its effects today in the distribution of plants and animals around the world. It's like nature's own experiment in parallel evolution, conducted on a scale so massive that it shaped the entire tree of life. But here's where our story takes a turn that will absolutely blow your mind. Pangaea wasn't the first supercontinent. It wasn't even the second or third. Scientists have now identified evidence of at least 6 major supercontinents that have formed and broken apart over Earth's history. And each one was stranger and more mysterious than the last. Before Pangaea, there was Pangaea, a supercontinent that existed around 600 million years ago. But Pangaea was different from Pangaea in ways that challenge everything we think we know about how continents behave. while Pangaea was relatively stable for about 100 million years. Pangaea was a geological speed demon that formed and broke apart in just 60 million years. Imagine continental drift on fast forward, creating and destroying entire oceans in what amounts to a geological blink of an eye. Even more mysterious was Rodinia, a supercontinent that dominated our planet over 1 billion years ago. Rodinia existed during what scientists call the Boring Billion, a period when evolution seemed to slow down dramatically. But recent discoveries suggest that Rodinia was anything but boring. This ancient landmass may have been responsible for one of the most dramatic climate changes in Earth's history, possibly triggering the first global ice age that turned our entire planet into a giant snowball. But wait, there's more. Scientists have recently discovered evidence of even older supercontinents, including one called Columbia that existed around 2 billion years ago, and possibly even older ones that formed when the Earth was so young that the atmosphere didn't even contain oxygen. These ancient supercontinents existed in a world so alien that it might as well have been a different planet entirely. Here's what makes these ancient supercontinents truly mysterious. They didn't just affect geography and climate. They fundamentally shaped the evolution of life itself. Each time a supercontinent formed, it created new opportunities for some species while driving others to extinction. Each time one broke apart, it scattered life across the globe in ways that set the stage for entirely new evolutionary experiments. Consider this mind-blowing fact. The formation and breakup of supercontinents may have been directly responsible for some of the most dramatic evolutionary leaps in Earth's history. The Cambrian explosion, that sudden burst of complex life forms that appeared around 540 million years ago, coincided almost perfectly with the breakup of Pangaea. The rise of land plants, the evolution of complex animals, even the development of intelligence itself, may all have been influenced by these massive geological rearrangements. But the mysteries don't stop there. Recent research has revealed that supercontinents don't just affect life on the surface. They actually change the way the entire planet works. When continents cluster together into a supercontinent, it affects everything from the way heat flows through the Earth's interior to the way the magnetic field behaves. It's like the planet has different operating modes, depending on how its landmasses are arranged. One of the most fascinating discoveries is that supercontinents seem to follow a rough cycle, forming and breaking apart approximately every 400 to 500 million years. Scientists call this the supercontinent cycle, and it's one of the most profound rhythms in Earth's history. But here's the kicker. We still don't fully understand what drives this cycle, or why it happens with such remarkable regularity. Some scientists think the supercontinent cycle is driven by changes in the way heat flows through the Earth's mantle. Others believe it's connected to changes in the planet's rotation or magnetic field. Still others think it might be related to asteroid impacts or other external factors. The truth is, we're still trying to solve one of the biggest puzzles in Earth science. What makes this mystery even more intriguing is that each supercontinent seems to have formed in a completely different way. Pangaea assembled gradually, with continents slowly converging over hundreds of millions of years. Pangaea, on the other hand, seems to have formed much more rapidly, possibly through a series of dramatic collisions that reshaped the entire planet in just a few tens of millions of years. Rodinia presents an even stranger puzzle. This ancient supercontinent may have formed through a process called true polar wander, where the entire solid Earth literally shifted relative to its rotation axis. Imagine the planet doing a slow-motion somersault, rearranging continents in ways that seem to defy the normal rules of plate tectonics. These different assembly mechanisms had profound effects on the supercontinents themselves and the life they supported. Gradually assembled supercontinents, like Pangaea, created stable interior regions that could support complex ecosystems for hundreds of millions of years. Rapidly assembled supercontinents like Pangaea were more geologically active, with more volcanoes, more mountain building, and more dramatic climate changes. But perhaps the most mysterious aspect of Earth's supercontinents is what happened in the spaces between them. When supercontinents broke apart, they didn't just split into smaller pieces. They created entirely new types of geological environments that had never existed before. New ocean basins formed, creating opportunities for marine life to evolve in ways that had never been possible. New continental margins developed, creating coastal environments that became hotbeds of evolutionary innovation. The breakup of supercontinents also created something called flood basalts, massive volcanic eruptions that could cover areas the size of entire countries with lava hundreds of meters thick. These eruptions were so massive that they changed the chemistry of the entire atmosphere and oceans, sometimes triggering mass extinctions that wiped out most life on Earth. But here's where the story gets really fascinating. Some scientists now believe that these massive volcanic eruptions weren't just random catastrophes. They may have been precisely timed geological events that helped reset the evolutionary clock, clearing the way for new forms of life to emerge and thrive. In other words, the supercontinents didn't just passively host life. They actively participated in shaping its evolution through carefully orchestrated geological catastrophes. This brings us to one of the most mind-bending implications of supercontinent research. If supercontinents have been forming and breaking apart for billions of years, and if each cycle has fundamentally shaped the evolution of life, then the existence of complex life on Earth may not be just a happy accident. It may be the inevitable result of a planet-scale process that has been fine-tuning the conditions for life over geological time. Think about it this way. Earth isn't just a rock with some water on it that happened to develop life. It's a complex, dynamic system where the solid Earth, the oceans, the atmosphere, and life itself are all interconnected parts of a single, evolving whole. The supercontinents aren't separate from this system. They are the system, at least the part that operates on the longest time scales. This realization has profound implications for our understanding of our own place in the cosmos. If Earth's supercontinents have been actively shaping evolution for billions of years, then intelligence itself may be the product of this planet-scale process. We're not just observers of Earth's geological history. We're participants in it, possibly even its intended outcome. But the mysteries don't end with the past. Scientists are now using their understanding of ancient supercontinents to predict what might happen in the future. And the predictions are nothing short of spectacular. In about 250 million years, the continents are expected to come together again, forming a new supercontinent that researchers have tentatively named Pangaea Ultima. This future supercontinent won't just be bigger than anything that exists today. It will be fundamentally different from any supercontinent that has ever existed before. For one thing, it will form on a planet with a mature, oxygen-rich atmosphere and complex life forms. For another, it will form on a planet that's significantly older, with different internal heat flows and possibly even different rules of plate tectonics. Some models suggest that Pangaea Ultima will be so large and so isolated from the oceans that its interior will become virtually uninhabitable, with temperatures so extreme that even the most heat-adapted life forms won't be able to survive. Other models suggest that this future supercontinent will create new opportunities for life to evolve in ways we can't even imagine. But here's the really mind-bending part. By the time Pangaea Ultima forms, the sun will be significantly brighter than it is today, possibly making Earth too hot to support life as we know it. This means that the next supercontinent cycle might be the last one that supports complex life on Earth. We're literally living during one of the final chapters of our planet's biological story. However, there's another possibility that's even more intriguing. Some scientists speculate that by the time Pangaea Ultima forms, life on Earth will have become so sophisticated that it will be able to actively participate in shaping the supercontinent itself. Instead of being passive passengers on drifting continents, future life forms might be able to influence the very processes of plate tectonics, essentially taking control of the planetary machinery that has been shaping evolution for billions of years. This brings us to perhaps the most profound mystery of all. What role, if any, does life play in the supercontinent cycle? We know that life has been profoundly shaped by supercontinents, but have supercontinents been shaped by life? This question is at the cutting edge of current research, and the answers are starting to suggest that the relationship between life and geology is far more intimate than anyone ever imagined. Recent studies have shown that life can influence plate tectonics through a variety of mechanisms. Living organisms affect the chemistry of rocks and sediments. They influence the flow of water through the crust. They even affect the way continents erode and sediments accumulate. Over geological timescales, these biological influences might actually affect the way continents move and collide. If this is true, then the supercontinents aren't just geological phenomena that happen to affect life. They're the product of a complex feedback loop between life and geology that has been operating for billions of years. In other words, Earth's supercontinents might be as much biological constructions as they are geological ones. This possibility opens up entirely new ways of thinking about our planet and our place on it. If life has been actively participating in shaping supercontinents, then we're not just products of geological processes, we're partners in them. And if we're partners in geological processes, then we might have a responsibility to understand and care for the planetary systems that created us. The study of ancient supercontinents isn't just an academic exercise in deep-time geology. It's a window into the fundamental nature of our planet and our relationship with it. Every time we discover something new about these ancient landmasses, we're learning something new about ourselves and our place in the cosmos. As we stand here today on the fragments of Pangaea scattered across the globe, we're witnesses to one phase of a process that has been going on for billions of years and will continue for billions more. We're living in the spaces between supercontinents, in a brief interlude between the massive geological movements that define our planet's deepest rhythms. But we're not just witnesses. We're participants, possibly even conscious participants for the first time in Earth's history. The knowledge we're gaining about supercontinents isn't just satisfying our curiosity about the past. It's giving us the tools we might need to help shape the future. And that, perhaps, is the most mysterious and exciting aspect of the supercontinent story. The possibility that consciousness itself might be evolution's answer to the challenge of surviving in a world where continents drift and supercontinents rise and fall like geological tides. The forgotten labyrinths of Earth's ancient supercontinents aren't just relics of a distant past. They're roadmaps to a future where life and geology might finally become conscious partners in the grand dance of planetary evolution. And that's a mystery worth exploring, no matter how deep into geological time it takes us to understand it.